Hello everyone, this video is about parallel and perpendicular lines. So we have the red line, y equals 2x plus 3. The gradient is of course 2, and y equals 2x minus 1, the gradient is of course 2. They are parallel because no matter how long you extend the line, they will never meet. So you can extend the line forever in this direction, they will never meet. Extend the line this direction, again they will never meet. Perpendicular line means forming a right angle 90 degrees. So let's say we have this red line and this green line. They are perpendicular if they form 90 degrees. So if they are perpendicular, the gradients or the product of the gradients must be minus 1. If we multiply m1 times m2, we have to get minus 1, or in other words, the other m or one gradient is minus 1 over the other gradient. So for example, if we have the first gradient is 2, for parallel relationship, the next gradient or the other gradient must be exactly the same, also 2. If it's perpendicular, then it's minus 1 over the other gradient, so minus 1 over 2. So for the next example, 3 also 3, 1 also 1, k also k, minus 4 over 5 also minus 4 over 5, undefined also undefined, and 0 also 0. For perpendicular lines, it's gotta be the opposite. So if this original gradient is 3, the other gradient must be negative something, positive, negative, opposite, and it's the reciprocal, 3 1 over 3. So it's for positive 3, the pair is 1 minus 1 over 3. For 1, the pair is minus 1 over 1, which is minus 1. For k, minus 1 over k. For the minus 4 over 5, the opposite of minus, so plus, and not 4 over 5 but 5 over 4, the reciprocal. And if it's undefined means the gradient is something divided by 0. So it's perpendicular to 0 divided by something, which is 0. So undefined here is because the line is actually vertical, and of course a line which is perpendicular to a vertical line must be a horizontal line. So if it's horizontal, the gradient is 0. If it's vertical, the gradient is undefined. And if the gradient is 0, the perpendicular gradient must be undefined then, because this is about vertical horizontal lines. Now tangent and normal lines. Tangent line means the line that touches the curve, or the line that has only one point of intersection, exactly one point of intersection. So the red line is the tangent line here. The blue line is called the normal line. So the normal line is perpendicular to the tangent line, and it passes through the same point of contact. Here we have a point of contact between the tangent and the curve, or between the normal and the curve. So perpendicular to the tangent, and we have the same point of contact. And another example, this is the tangent touching, and this is the normal perpendicular to the tangent through the same point of contact. Perpendicular bisector. Perpendicular means m1 times m2 equals minus 1, and bisector means bisecting or dividing into two equal segments. So if it's a bisector, then the line passes through the midpoint. So we have point A and B. This is the perpendicular bisector. The red line is the perpendicular bisector. The green line is the line segment AB. To find the gradient, you can use delta y over delta x. So the gradient of the green line, we would call it M1 or MAB. And for the gradient of the perpendicular bisector, because it's perpendicular, it's gotta be minus 1 over MAB. So remember, it passes through the midpoint. Example question here. Find the equation of the perpendicular bisector A minus 3 minus 4 and B minus 7 minus 6. So the first thing to do here is to visualize things. You can just draw a simple sketch. We have A, B, and this is the midpoint. You can find the midpoint. So the first step here is to find the gradient of the green line. We can use delta y over delta x. Second step is to find the gradient of the perpendicular bisector. Remember, it's perpendicular. And then you can find the midpoint using the midpoint formula. And then after you have the midpoint and the line, the gradient of the tangent line, you can use the y minus y1 formula. Of course, you have to use the gradient of the perpendicular bisector, which is minus 2, and you have to use the point passed by the perpendicular bisector line. So we have to use the midpoint. We cannot use the A point or the point B because they are not on the perpendicular bisector line. So yeah, using the gradient and the midpoint, we can find the equation of the perpendicular bisector. That's it. I'll see you again next time.